to please come on stage to felicitate our guest.
At the end, I think you should do it at the end.
Okay, we'll do it at the end. Thank you. Okay, sir.
Good evening. Am I audible at the back? Fine. So today I shall talk about, I've chosen a topic, celebrating AI. Now for celebrating AI, I shall try to get into a different pathway to look at AI from different perspectives, and not just a traditional way it is looked at by a computer scientist. Because AI, in my perception, is actually emerging to be a core scientific subject, scientific space, for various reasons. In fact, if you look into it, the context in which we are today is placing AI at a different platform from many of the engineering disciplines, or also aligning it very closely to the philosophy of emergence of engineering disciplines. So my talk is celebrating AI, trying to look at AI from a different perspective. And interestingly, I think the students should be knowing definitely of this matrix and the character Morpheus. And in that comics, in that whole comic space, this is something from there, okay? It was stated that at some point in early 21st century, all of mankind was united in celebration. We marveled at our own magnificence as we gave birth to AI. I hope you can understand the context with which it has come. And the way it's a kind of a prophecy came true, in the sense that when we celebrated this year, the 2 Nobel Prizes, okay, both in physics as well as in chemistry, are linked with AI. And different aspects of AI, which in a sense actually has recognized AI as a science, which is a controversial context, controversial topic at different quarters, but it's a fact that with 2 Nobel Prizes coming in AI. And before that also, if you remember, I think many of you must be knowing that a computer scientist got a prize, Nobel Prize, in economics. Okay? So computer science is also moving along with AI, becoming truly a science. Now this is something is very, very important to celebrate, and that's exactly why I have chosen the title of my talk as Celebration of AI. Now, if you look at the mystery of human intelligence, in fact, the mystery has troubled human thinkers since they first became sentient. That means, if you look at from an evolutionary perspective, when the evolution made human beings sentient, that means conscious, from that point onwards, this whole mystery of intelligence was actually explored. In fact, if you see in terms of our ancient scriptures, in mythologies globally, this intelligence has been actually looked at and thought about. Now, what is intelligence? What aspects of human nature allows them to possess it? I think this is a very key question which has got a huge scientific implication. And therefore, as living systems, we need to understand how we are different from other living species. We are, and that's why the civilization is. And that's because of the human, we say commonly that's because of human intelligence. But what is that intelligence? If we do not know what is that intelligence, we cannot talk about something which is artificial intelligence. So if you look at it from a concept of discovery to invention and innovation, this exploration of what is human intelligence is actually the discovery science. Just like I have physics, we have chemistry, we need to discover, we need to unearth what is there in what is our brain, what is our intelligence. And the unearthing process gives rise to what? Gives rise to principles. We discover principles. The way we have discovered physical laws which governs nature, these are also laws which are governing nature, the nature of intelligence. And if we can decipher that governance, that nature of intelligence, we can actually get into the path of innovation or translation, which gives rise to artifacts which are intelligent. I think this is something which is very, very important. See, physics enabled us to understand the principles of electromagnetic wave propagation. That was a discovery. Because of that discovery, today, if you look into it, I have mobile phone and mobile communication, which is actually an invention and translation from the discovery process. Today, what we are seeing in the AI space is exactly that. And that's why it's a very exciting time to look at that we are looking into the science of brain, and motivated by the science of brain, we are trying to make things which can emulate our intelligence. But I'm not telling that today what we are doing are exactly what happens in our brain. It's not. There's a gap. But we are actually moving in that direction of discovering, that is the inventions, and inventions to be translated to something tangible, product and outcome. So therefore, as living system, we need to understand how we are different from other living species. In fact, I shall talk about one principle of human beings, that of educability of human beings. In fact, this concept was brought in by another computer scientist who got Turing Award 2 years back. This is a very recent book of his, that educability of human beings. Human beings have the capability of being educable. And this is an interesting word to look at. Educability can be defined in terms of, this is from his hypothesis, learning from experience, being teachable by instruction, and combining and applying learning obtained in both modes. If you look at these features, no other living being actually satisfies these properties. So educability is talked about and is actually identified as a feature which makes human beings different. And what are the key aspects of human learning in this case? Learning from examples and generalize from examples are features of learning from experience. We all know in the AI, we all do examples and example-driven learning. Then ability to assimilate and follow instructions is the second most important thing. You can also can instruct maybe your pet to follow an instruction. Fine? But the assimilate, look at this word assimilate. Your pet doesn't assimilate the instructions. Pet follows the instruction. Okay? And that assimilation is actually gives rise to third aspect, which indicates the capability to chain and apply rules learned from experience and rules acquired through instruction. Fine? Now, therefore, we know we have the ability to learn. See, the point is that everyone is here is because you have the ability to learn. Okay? And the remarkable educability of human brain can be understood as an information processing ability. And I shall come back to this information processing towards the end of the talk, how the theories of cognition and intelligence started talking with information processing. In fact, if you have done a course on computer vision and come across David Mer's theory of vision, he talked about vision as an information processing in brain. Okay? It sets our species apart. It enables the civilization we have and gives us the power and potential to manage our planet. Now, this is a philosophically extremely significant. So, if you see humans are capable of abstract thought, imagining and creating things that may not lie in the realm of possible existence. Okay? They are creative in addition to rational, spontaneously forming new ideas without any apparent inspiration. But inspirations are there embedded. But so these are two things. If you look into these two aspects, these two aspects today are not there in today's AI. Definitely not there. Okay? If you look at it, abstract thought, imagining and creating things that may not even lie in the realm of possible world. See, the point is, that's why I gave an example to start with. The physics enables us to discover the laws of electromagnetic wave propagation. It was natural. It is not created by human being. It has been discovered by human being. But mobile phone is not natural. It has been created by human being and created in a sense that out of realm of possibilities. In fact, it took years to emerge as a possibility, but it's not natural. Right? So the point is this alignment of what is there with AI is something very, very important for us to understand and appreciate. Educability is a unique characteristic of human beings responsible for creation of civilization, knowledge and culture at a vast scale. And the cognitive capability that makes creation of culture and knowledge possible occurs only with humans. These are all observations. Science starts with observation. Educability is the observation. We do not know how educability emerges. Okay? So the world of intelligence, natural or artificial, therefore there is abundance of exciting possibilities. And in fact, this Nobel Prize has actually brought that exciting possibilities into the focus, and that actually enables us to think about AI in a completely different way. This has been the classical Encyclopedia Britannica definition, which, if you see, this definition reflects a popular culture where AI gets linked with computing. Fine? So far what I talked about educability and human intelligence. And if you come to this popular concept of AI is emulating the intelligence, trying to realize intelligence, but it has been linked with computation. It is definitely linked with computations, but whether electronic computer is the only vehicle for realization of these or not, we do not know. We are currently using it. Fine? But there are also at the same time various interesting researches are happening. If you say DNA computing based AI is something which is being pursued, and in very recent times what are being done is what is called organoid intelligence. If you look at a very recent paper in Nature, it talks about organoid intelligence, because those who are working in biological sciences know that today there is lots of petri dish organoids are being created for, say, tumor samples. Organoids are being used as a basic research area in biosciences for primarily medical requirements. But initiatives have happened actually from brain cells to generate organoids which can be brainoids. Okay? And can I use that brain, the brain infra to do AI? That actually will change the nature of AI. Fine. These are all possibilities which are coming up when we are trying to look at the science of AI and not just computing of AI. Okay, so this is something which is extremely important to think through, because AI is there, human intelligence is there, and the connecting pathway has tremendous opportunities and possibilities, and computing is not the only pathway. If you look into it, AI prehistory, because AI has, and why I'm showing this prehistory is, if you look at it, it has primarily been what? Mathematicians, and mathematicians were concerned with computing, and they have defined the prehistory of AI. Was there a perfect prehistory? We do not know. Only thing we can say that that prehistory has successfully emerged to give the Hopfield and Hinton the Nobel Prize in physics, and AlphaFold as a Nobel Prize in chemistry, because the tool used in AlphaFold is AI-driven tool. The entire generative AI-driven tool has been used for the protein synthesis and trying to understand the AlphaFold. Okay? Which one? Let's come to the questions maybe slightly later on. I'm not telling perfection. What I'm telling is that this question we do not know. This is the pathway which has been followed for computing as emerging as a platform for AI. Okay, so I'm raising that question. I'm raising that question because human has abilities, and that science, the point I drew the analogy to actually excite lots of young people who are here to look at things in a different way, not to discover another algorithm, yet another algorithm for training and doing LLMs. So this is the whole story. If you see that people have gone through, and with expert systems, then blocks world, the dependency graphs. In fact, interestingly, if you see conceptual dependency graphs, which are precursor to today's what is called knowledge graphs. And knowledge graphs actually capture your domain knowledge. Why want to touch upon knowledge graph? Because obviously, it's not that if I say the educability of human mind, the educability of the human mind also implies that it also has a formal structure to encode what it is learning so that it can use it subsequently. So encoding of your knowledge, it's not neural networks. Okay? Encoding of the knowledge possibly is not neural networks. Encoding of the knowledge can be something else. In fact, neural networks can be a possible platform for encoding knowledge, okay, medium for encoding knowledge, but knowledge as an explicit representational scheme is something very, very important to look at, and the question is how in your brain the knowledge gets stored and represented. So currently the dominant AI is neural networks, which emerged in 1940s and 50s, not today. Okay, if you see the backpropagation algorithm that we are so excited about, it was reinvention by Rubenhardt, Hinton and others. It's a reinvention. It was not originally, it was there much before that.
Why Paul Verboes was not selected?
That's a Nobel Committee's decision. Okay.
Because if you look at,
He was
he
this
is the original.
absolutely. But it was, why the physics? It was a physics decision. I shall try to come to that slightly later on when I talk about that explicitly. And if you see, it was a very interesting thing is that the University Summer Conference in 1956, which established AI as a discipline, and it came from computing itself. So this is a time when we should actually go back and remember them, because what they had done, today we got the outcome of that whole process. In fact, they have actually represented different aspects of AI altogether. I won't go through it, but all of them were there when this Dartmouth Summer Research Project on AI was declared. It was 1956. if you see 1956 as a starting point of AI research, actually trying to understand brain has happened long back, is happening for years altogether. Okay? But 1956 is the starting point of a formal computing based AI. Okay? Then if you see that it has taken how many years? If you look at it, it's more than 60 years, okay, to come to the forefront. Okay? And that's also something important to note, that how long does a field takes time to mature when it is completely a novel and comes out from a different culture altogether. See, physics never took so many years to establish itself. Physics theories, they have waited because of experimental verification. But this whole cultural shift of trying to look at science from a different lens took at least 60 years. So now if you look into it, that some of the things which chess, significant things is chess 1978, then this Boris chess player, it was a device in 1979. Then there was this fantasies of using AI in diplomacy, generic sequential decision making, machine and governor, and general sequential decision making has been used in a number of different areas, including economics. Chess playing, automatic translation, computer vision. This problem started way back 60s. But even today we have not always got a very satisfactory results. It has improved substantially, but still there are scopes of improvement and things to happen. So AI, if you see this computational pathway of AI is something which is going on. And the philosophical perspective was brought to by AI, by Norbert Wiener's vision, who actually introduced the whole term of cybernetics. So cybernetics, when he came with that idea, it was in the time when, because this whole thing has been picked up, the Max Planck Neuroscience have this on 25th April 24, is where they actually try to look back at Norbert Wiener and his contributions. Because he talked about problem solving machines, he talked about machines making machines, and acceleration of progress in making machines. So if you see, this actually is a cybernetic vision of technology, and all problem solving today computers and all these techniques that we are emerging and creating through AI are nothing but a variety of problem solving machines. And machines making machines is what is, if you look at it, that self-producing machines. Okay? Now this is again a concept that a robo making another robo. It's not that it's not happening. Okay? Robo making another robo, it's not that it is not happening. And this was a concept in terms of actually bringing in a biological perspective to mechanistic system. Okay? So because if you see, cybernetics is actually looks at things in a holistic fashion. And why I brought in cybernetics is because here, with AI and human intelligence and artificial intelligence, everything coming together, we are going back to that cybernetic philosophy of an integrated world, integrated perception. And he talked about self-improving machines. Now, that is the whole concept of what we today talk about learning. And we have got supervised and unsupervised learning and a variety of them. And interestingly, supervised and unsupervised learning were the very classical things that we came up. But there has been a variety of other forms. If you say reinforcement learning, then we have also semi-supervised learnings. There is a range of these learning technologies, one-shot learning. Then we have actually learning with this curriculum learning. So there's a variety of learning which has come from an algorithmic perspective. But foundationally, if you look at, these are the two basic things, that supervised learning or unsupervised learning. And reinforcement learning is something where is a variant of unsupervised learning, actually. Why? Because you get the feedback, not pre-specified feedback, but feedback from the environment. And feedback from the environment, we shall see to it later on, that also lets into this whole perception cycle, which enables you to understand the world. So therefore, say classification is an unsupervised and supervised, then image captioning, because these are, if you see, these are the advancements which has happened in computer vision. I knew how to recognize an object. ImageNet was a kind of a breakthrough event for recognition of objects, but not image captioning. Okay? Image captioning is actually description. So discrimination and generation, these are two distinct aspects. Okay? So recognition, if you see, recognition is actually discrimination. I have the ability to recognize a cat. A child has the ability to recognize cat, but child cannot always provide a description of what it is looking at. So if you see, therefore, in the concept of intelligence, ability to describe, ability to generate is actually the second level of your intelligence, okay, in terms of the ability to do things. It is not just getting the instruction, but on the basis of instruction, ability to do things, which has talked about educability, which actually in terms of algorithmic framework, this becomes actually classification. In a vision, example is classification to that of image captioning, a description generation. Then this object detection is and supervised semantic segmentation, because these are all, I'm looking at vision because I'm showing you that these all required algorithms and techniques to develop. Because I cannot classify, and this is, if you see, I am detecting an object, fine? Because I know the kind of object I want to see. Here, when I am segmenting, I am just segmenting on the basis of colors. So it's an unsupervised categorization. So, in fact, learn some underlying hidden structure of the data. So segmentation in that sense is learning the hidden structure of the data. Clustering, so K-means clustering is the most common algorithm we know, and PCA, that's actually a dimensionality reduction. Now why dimensionality reduction comes in over here? If you look into all sciences have actually done a kind of representational scheme where we can look at things in a better way by transforming one space to another. Now what is the significance of PCA with reference to AI and data? Okay? Because PCA actually was the first technique which came into being, statistical technique, which actually talks about the different space of representation of a data points. If you look at conceptually, when you talk about animals, that's a one space you are looking at. When you're talking about dogs, that's another space you're looking at. When you're talking about leaves, that's another space you're looking at. So conceptual categorization is also space specific. Okay? And PCA actually looked at a transformation in a data space of creating spaces with specific purposes. In fact, there are all variants of these things. And while doing all of these, people did not forget the problem of brain. The point I was trying to look at. These I'm looking at from a point of view of solving a problem, but at the same time, when you look at the neuron, all these things turns out that brain processes them in this identical way? If not, then we should try to look at the neurons per se, and using the neurons try to create the techniques. In fact, this is exactly what is a LeeKuhn's 1989 paper. In fact, I would say that why LeeKuhn did not get it is also a question, because before Hinton actually, but Hinton had variety of other contributions, but LeeKuhn became 1989. He worked with the model of Fukushima and actually got this recognition done. This is a very robust recognition engine that was developed. See, if you look into it, at that time, handwritten numeral recognition was a problem which was very widely being researched, because it was also important for practical engineering application of sorting letters, address sorting. Address sorting was a major problem. And there people have come up with variety of solutions. In fact, that's why the handwritten digit recognition was a challenge. And this LeeKuhn's idea came from Fukushima's work, which actually was, if you look into it, that variety of data which came up, and this is also social computing and crowdsourcing comes up. And data collection, if you see, CAPTCHA we use always, but why CAPTCHA came up? CAPTCHA was introduced for the purpose of collection of data, because variety of forms the data would come up, and so that would be CAPTCHA is also, if you look into it, you generate artificially the labels, and you use the CAPTCHA to break the label and give the human being to write down what it is. By that you use what is called a Turk for the purpose of labeling the unknown data. So this is where we are moving into data. If you see, so far, whatever I talked about, all these had data, but whenever I have come to this kind of a recognition engine, there is a huge volume of data, and hence the data collection becomes actually a challenge. So large data sets. Now therefore, if you look into it, the breakthrough point also came when my computer has the ability to handle very large data sets, and that's why these large data sets were created. And ImageNet classification data set was a challenge, and that challenge was resolved and done through actually using convolutional networks. But precursor to the convolutional networks actually was LeeKuhn's network, which I showed. Okay? And he became, in fact, this is the most interesting thing, he became actually his work was in the Rolling Stones magazine. Okay? He became a hero, rock hero, because most of our AI research focus on understanding the meaning of what people share. Okay? This was a Zuckerberg statement. And Zuckerberg actually figured out that what LeeKuhn had done, okay, has so huge potential for converting Facebook a money-making platform. And that's why he became, in a sense, a rock star. So why I brought in this, if you look into it, here another aspect comes up in terms of AI, which is not to be really celebrating about, is a monopolistic or hegemonistic aspect of AI. Because these big corporations, this is actually, Zuckerberg realized that, and LeeKuhn was appointed there, and if you see today, all AI scientists are appointed on all of these companies. Okay? In fact, your Facebook, X, and all of these companies are actually Microsoft, they are appointing them, because what it is doing is that they have mechanisms to collect data. Data has become the basic driver of new technology, validation of technologies. Okay? And this data is getting monopolized. And I shall come to another point of AI, negative part of the AI, as they move forward. But this is the first time that monopolistic approach in terms of data and exploitation of your personal data without your permission. Facebook is today exploiting your data without your permission. Google is exploiting your data without your permission. We talk about all these data rights, data laws, etc., etc. But this is actually a kind of an impact of AI. I have talked about so far the positives of AI, why Hinton left Google. Hinton also left Google because he said that once these LLMs came, and it says that it has a potential of an destruction of that of an atomic bomb, and he didn't want to be part of it. The starting point of atomic bomb research is actually this point. Okay? And I shall just come to it as I move forward. Now, at this point, you have to see how physics comes in AI. Okay? So, the Hopfield network, which was Hopfield came up with, utilizes a physics that describes a material's characteristic due to its atomic spin. Fine? See, look into it that I need data. Fine? And data is used for recognition. So, I need to store data in an efficient way so that I can recognize easily. Those who know general computer sciences, if I just store the data in a list, okay, and if I want to recognize whether I have that data there or not, I have to search linearly over there. Now, just imagine, see, neural networks also what it does, it actually, if you look at LeCun's model wise, even say your the standard convolutional net based model wise, the recognition actually, the large recognition means you have to scale up also the network. As you scale up the network, what happens? Your requisite resources also increase. Now, and that is actually getting embedded in the links of the network, that knowledge about the objects. Now, there can be an alternate view of that, which comes from a physics perspective in terms of if I creating an energy surface with a control number of minima, okay, and at each of these minima, I can store these objects. What does it mean? That means the object can have variations and variabilities, but all of these variabilities put together are attracted towards the minima. Okay? So, if you see this picture, look at this picture. The Hopfield network generates an energy surface, fine? Because it's a completely connected network. Think in terms of completely connected network where there is an excitement happening all the while. So, because of this excitement is actually generating an energy surface. So, I have a set of particles, these particles together because of their interactions generate energy, okay? And so, I have an energy surface. If I have a rule to control that energy surface in terms of fixed minima, and those minima represents the different object categories, then the whole data structure of representation of or storage of information changes. So, physics contributes that dynamical systems concept of physics comes in to contribute the formulation of memory. Okay? So, in fact, there has been a variety of work related to these, which actually has looked at the different stable positions of Hopfield and its applications in terms of, this is the simplest application which was there, is that different shapes are stored, and because of this minima, even if there are noise, that noisy data actually gets settled into the minima, and hence you can recognize the objects despite the noise. Okay? Which actually, if you look into it, if you look at your classical neural network based approach, in ImageNet, I think I'm assuming neural network is commonly known to all of you. Neural networks are learning what? Learning distributions. Okay? Because for each category, they are estimating the distributions. It's not like an analytical distribution, but it's learning the statistical distribution. It need not be Gaussian distribution, but something else. But that's what it's learning, and hence it's recognizing with respect to that. Here, actually, if you look into it, this minima is a representation of those distributions. Try to connect the two things, that from a probabilistic perspective, where we look at the machine learning, the neural networks in terms of learning distributions, this is also learning the distributions. But what is important? Our all machine learning systems actually fail when there is a drift. That means I have a data belonging to that distribution, but it is not part of the distribution which is learned by neural network, then that network fails to recognize. Now look at your Hopfield net, they are all minimas. If it lies on the gradient, then it will pull towards the minima. So it is inherently expected to be more robust to drifts. Okay? So it's inherently expected to be more robust to drift, because in this case you are learning a distribution that and it has to be the distributional parameters doesn't, it's only in terms of the maximum winner that you are trying to look at, but still the distribution is there. But if you can control the surface sufficiently enough, you can actually make it more robust. Okay? So therefore it gives you a different perspective, a different way of looking at classification problem. Now look at physics plus AI, where Hinton comes in. Hinton used the idea, or collaborated with, in fact, with the Hopfield net, because what is your Hopfield net? Hopfield net is, these are different kinds of networks where Hopfield network is all the nodes are connected. Okay? All the nodes are connected. I do not distinguish between what is input node or what is output node. But when I come to Boltzmann machine, there are two classes of nodes. We talk about hidden nodes and visible nodes. Okay? That means the symmetry of the nodes which was there in Hopfield network, it's not there in Boltzmann machines, which was actually Hinton. So it is, again, look at that point which I said is, it looks at statistical distribution of patterns. It contains visible nodes that correspond to patterns to be learned, as well as additional hidden nodes, where the latter included to enable modeling of more general probability distributions. Are you getting my point? The point I was hitting on, that if it is more general, then it's more drift resistant. So the whole philosophy is, actually if you look into it, how robustly I can capture the distributions. Fine? Now, therefore, the statistical physics, statistics, physics, and pattern recognition all converges into one unified framework when you look at this. So if you have all of these together, if you see that Hopfield network, Boltzmann machine, and restricted Boltzmann machine, because restricted Boltzmann machine is here what we do not have the connection between the nodes of same category. Okay? If you see hidden nodes are connected to visible nodes, but hidden nodes are not connected to hidden nodes, visible nodes are not connected to hidden nodes. These becomes restricted Boltzmann machine and almost similar to your what? The feed-forward networks, but not exactly feed-forward networks, because I can train them independently. And in fact, if you see what is the contribution of Hinton to deep network thing, is that deep network has multiple layers, many layers. Okay? So actually Hinton came up with this framework so that you can do a structured trading of each layer separately and then connect it together. And obviously with that, that's resolving this problem of vanishing gradient was also there, but it's important. Look at your autoencoder. Autoencoder is trained separately, because I can train autoencoder with my input as same as that of the output. Okay? So the point is that this restricted Boltzmann machine, so that way Hinton contributed towards the entire framework of deep learning by using these restricted Boltzmann machine concept and bringing in for training of deep network. The whole idea of the other part of it was earlier, which came from Fukushima, and if you look into it, therefore, the CNN architecture had its root in the neocognitron method by Fukushima Fukushima, who in turn was inspired by the work of David Hubel and Torsten Wiesel, the Nobel Prize laureates in medicine in 1981. And CNN approach was developed by LeCun, but what is very, very important is that this multi-network layered network training, efficiently training multi-layered network was done by these people. So I shall not look into this. If you go back and look at this picture, this was actually the feature hierarchy of eyes, which was provided by the Nobel Prize winners, and this feature hierarchy with reference to eyes. This actually motivated that deep network framework of convolution layer. So if you see in convolution layer, what we get is a feature hierarchy, which was what the visual pathway, and this whole visual pathway was actually as part of this framework. So this is what I think is all of us know. And generative modeling is, if you look into it, given training data, generate new models from same distribution. Now, this is exactly the generative part which I talked about, is that the all others that we talked about so far is the discriminative part. But the rest of it becomes the generative part, which is actually the generative modeling in terms of given the data, given the distribution, can I generate more examples from that distribution? And that actually gives rise to a different set of algorithms altogether. Okay? And so if you see there are so many fantastic things which are happening simply because of, if you look at diffusion model, what is diffusion model? Diffusion model is you are learning distributions in terms of adding noise to the data, and from there you're removing the noise to generate new images. Just think in terms of a classical diffusion model. I take up a set of images, okay? I add noise with a specific conditional distribution, and as I add noise, I get finally a Gaussian distribution, fine? Based on the images that I have given as input. From Gaussian distribution, I generate other points. I generate other points means I generate new images. So you just think in terms of creativity, you can take any painter's, say Van Gogh's paintings, okay, create a Gaussian distribution out of Van Gogh's painting, and then do a generation of the points from that distribution. So you generate Van Gogh's painting, which was never there in the world. So what is happening is you are also bringing in a creativity. Now the whole question comes up, it's a question of ethics. Is that really original or fake? Fine. The question is today everybody is talking about fake videos, etc., but there has been exhibitions, art exhibitions using this way of generating paintings. So the whole concept of fake and non-fake in terms of statistics actually coming up in a different way. So try to understand this. This is from a philosophical perspective, this is also a definition of creativity. Your creativity has enabled you to sample some of these points over the space of possibilities. That has been your talent. And you have given me those things, since I know they have been generated from a distribution, I have generated the technology to actually generate more such examples. Okay? So it is not undermining somebody's talent. It's actually recognizing somebody's talent and being able to do more than what he has done, because you have actually understood the science of the data to go into new space of creativity. Okay, and these are something very, very interesting interpretations you should look at. I've tried to avoid the maths of it completely, but if you see, this is a taxonomy of the generative models, and all of these are nothing but different way of estimating the densities. The people who are coming from maths or statistics background, you will see that this is nothing but statistics. But what statistics has never talked about is how to generate a sample from that distribution. Because statisticians typically looked at how to model the distribution. And now the thing comes up as how you actually put in conditions to generate the points from the distribution. That gives rise to the entire creativity. If you see today, the entire space of generative AI and generating pictures, generating text, generating your LLM with reference to the query, all are based on the whole idea that these, if you look at, say, LLM, okay? LLMs are these transformers. I won't go into transformers. Look at what are philosophical LLMs. Your OpenAI and all has trained on your entire Wikipedia. Just consider, they have done it on more also. They've trained on whole Wikipedia as well as your English books. So what it has done? It has actually generated the distribution. Look at from a diffusion model perspective, generated the distribution of all such possible combinations. Transformers are nothing but interesting ways to look into the linguistic constraints in terms of modeling those distributions. So if I have all possible distributions of sentences, just imagine the way you can write a sentence in a language, if that is represented as a distribution and pick up a point from that distribution, then you can generate any text by any author. Okay? And the problem is, what is missing all these things? The problem is human beings have the causality. You have the physics. Okay? The physics is not coming here. It's only statistics, so you can generate a statistically valid sentence. It can generate a sentence like Santanu Chaudhury is director of IIT Delhi. Because statistically this is possible because there is director, there is IIT, there is Delhi, there is Santanu Chaudhury. But it's not causally valid. It's not factually valid. So the factual validation or the causality which physics imposes is completely missing today in all of these generative models, which is fundamentally an open challenge, because when we generate, the causality is implicit and implied. So this brings us to the whole question of trustworthiness of AI. Okay? So I can rely on a human being, you cannot also rely on always a human being, but at the same time, if the AI does not have today's causality, the point I was trying to talk about, then the question comes is can it be trustworthy? Can it explain what it does? There can be explainability, but trustworthiness is not just explainability. So the biggest gap today's AI is actually bringing in the whole framework of causality in both discriminative space as well as generative space. Why in discriminative space? In a discriminative space, if you slightly modify, let's say, appearance of a cat, okay? Now, or cat, there is some noise to the cat shape, what will happen? It will be represented as a drift. So a typical ImageNet, when it's trying to recognize a cat, it will not recognize as a cat because of some additional features that you have added to the cat. But if you have a causality built into it, it will say it's still a cat, and that's an additional thing which is visible because of some noise. That's the explainability which comes through causality, because I know why it is a cat. So all the recognition engines doesn't talk about that at all. Fine? So therefore, the limitations of AI and where the educability part that I was talking about is missing is because we have not yet been able to model the causality. We have actually captured the physics. From physics, we have captured the energy space, representation of a knowledge in terms of energy, because that's also is aligned to the statistical concepts. But the causality part is what is missing. So again, the question of responsible AI is the practice of developing and using AI systems in a way that provides benefits to individuals, groups, and wider society while minimizing risk of negative consequences. This is exactly the reason why Hinton actually left the job of Google. Because your LLM can generate any kind of propaganda. generate any kind of descriptions, any material for that matter, because today you understand it's a question of intelligently selecting points in the distribution. Okay, it can imitate anybody's speech, the way of speaking, and can plug in something very dangerous. And if you see today, those kind of campaigns can be more dangerous than that of an atomic bomb. Okay? So this is something which is it's a negative part. So if you say that science has a positive part, science has a negative part, this is actually the negative part of AI which requires to be addressed. So we cannot trust these models. So now here what actually other part which has come in and is another thing which we have actually shown the educability, but also that brain science also inspired AI is something which is very important and which started with David Mer's work. But if you look into today, what is the theory of perception? Theory of perception and our perception which we do with AI, where there is a difference. This is a picture sentience which is from Quendrick books. He is a cognitive scientist. I think all of you who have worked in cognitive science knows about him. I am just trying to establish a link of cognitive science and AI, which in many cases we miss. So if you see that this is the view which in sentience he put forward, each organism has its own surrounding world. These are organisms' sensory and action world. It is determined by biology, bounds the universe from the perspective of the animal. Today's AI doesn't do that, because there are insects which has got not 2 eyes, but many eyes. And so therefore, his insect's view of the world is completely different than that of human being. Okay? And its interaction, therefore, the way that surrounding world for that animal is different, and its perception of the world is different. So if I today want to have a robo with multiple eyes, until unless I understand this, I cannot create algorithms for robo to actually operate more efficiently. Okay, so this is basically the whole philosophy which comes up with this, that why this cognitive science and the cognitive aspect of perception now is becoming more a driving force of AI. So if this is a picture from the famous book, Russell and Nordvig, it says that AI's point of view, if you say that for an environment you interact and see, get percepts, and based on percepts you act, and that's exactly what the world is all about. And this percept and action for an insect, for an animal, is different from that of a human being. Okay, so therefore, that context has to be brought in terms of this AI as well. So if you look at here, a reflex agent considers how the world is and choose action based only on current percept, do not consider the future consequences of the action. This is a reflex agent. Predictive agent is how the world would be. Decisions based on hypothesis of this. So these are the two different decision mechanisms, but what is important is these decision mechanisms are not without the percept of the world and with which he is bound. So my world, that human being's world, the way I look at this and a spider's world are different. Now this is something, we know, but why it is more important for us is because if we talk in terms of creating robos and other things which are manifestations of human being, then this whole concept of percept has to undergo a change. This actually came, another is awareness hypothesis, which is contributed by Schrodinger. Again, the physics coming in here. That source of organism sentience or awareness is discrepancies between predictions of the feedback mechanism and observed state of the world generate the sparks of awareness. Please try to follow this word. That expectation and the difference with the expectation actually generates an awareness. and it's in a very quantum sense. Okay, the quantum sense it comes in because it's not a completely predictive. Okay, so the point is that therefore he works in mind and matter psychological linking hypothesis that connects the functional tones to meanings and qualities, and this is something which puts a perception at a different context also. And so where again physics comes in, the uncertainty of the physics is very, very important here. And the whole connection is a curiosity-based exploration, because you can actually look into the different works and what is the reality, and based on the reality you move around and figure out what is predicted and what is reality. Okay, because if you see that same thing, that you actually find out the discrepancies, based on the discrepancies you figure out what it is. So this is interface theory of perception. Perception reconstructs and there is construction. Perception constructs. This is from a cognitive science point of view. And now if you look into it in parallel, the discriminative and generative point of view of AI, how it gets aligned. But we are not looking at it explicitly today, how to connect these two things in terms of dealing with the physical world and dealing with problems. So perception, now if you come to of these, perception is therefore fundamentally active creative process that generates theories about the world based on sensory input and retains a theory that best fits the input. So this is actually building up of knowledge. Learning that what we do so far is not building up of the knowledge, not building up the layer by layer the perception of the things. So this is so therefore perception is fundamentally active and creative process. Now what does it mean? Our neural networks are not fundamentally active. Okay, our generative model is not active, our discriminative models are not active. Active models are actually when I make a robot. And what is important is therefore the human intelligence, the sentience is not just a static perception. It's actually how we interact with the world, how world appears to you and how you can change the world. So therefore the whole pathway of AI, what we are talking about, and pathway of AI, and if you look at the human beings as inspirations, then there are lots of space to go. And recognition is what? If you see, this is an interesting picture. How you describe this picture? In fact, there is a famous picture, if you look at one of the famous computer vision books, where there is a train coming out of a building. Remember, some of you must be remembering that. But how do you describe that? Because that expectation is not there at all. So categories as bundles of cues that play a role in actions. So until unless you bring in actions, the functionality of the objects, you cannot bring in the concepts. So let's say this is something which is which we actually try to look at, that how the human recognition, process of recognition really contributes to the algorithm design. Because why this point comes up in this context? Because if it's a distorted character, if it's a ornamental character, a human being tries to look at it with different views, different perspective. It explores the character. It explores the character to actually understand what it is. So it is not a static one view decision. And based on that, your focus of attention changes. So because of focus of attention changes, you can actually combine evidences for the purpose of recognition. And it's a sequential evidence. Okay? So therefore perception has, and another very interesting thing is that what we are trying to look at today is that model of intelligence for how the children develops these capabilities. Can I create a model from there? And because these are all very interesting work, that the color cues comes in and gives you things which is much later on comes up. And so we are trying to set up a lab where we would like to work with born blind kids whose cataract can be removed, and when they get the sight back, how they start perceiving the world. Also how the color, sense of color enables. There are many ways. The example one we saw was how you actually learn to recognize characters. Because a child can recognize straight away written characters, but when there are distortions, it is not easy. It has to be more exploratory. So therefore, this whole thing is very interesting in the sense that why I came to the last part was that given the brain science, brain becomes still an inspiration for the AI to create theories. And last part is consciousness in AI. There can be various philosophical perspectives in terms of consciousness of AI. But what is important is today is a computational functionalism of AI. And why this computational functionalism AI is that consciousness in AI is possible in principle, that studying the workings of AI systems is relevant to determining whether they are likely to be conscious. If you know the LLMs, that whole concept of attentional reasoning, the attention based, because attention is one explicit example of an AI system being conscious of what are the other things in the sentence, in the text, in the scene. So therefore, computationally, the system is conscious. So therefore, artificial consciousness is one level beyond AI, but it's not something not there, it's there. There can be other computational perspective or philosophical perspectives can emerge, but that's actually the open space. So if you look into it, the interesting part of it is, I'm ending with this, that you start with educability of human beings. You explore the educability of the human beings to know what human beings can do. And that prompts you to explore AI. And as you go back and exploring AI, you need to get into your brain. You need to understand yourself. You are not looking outside. You are, in a traditional sense, looking inside. And the way you are looking inside, brain is not just maths or logic. Brain is also physics. If you go back and look into Roger Penrose's book of Emperor's New Mind, he actually talks about the physics of mind and how the physics can create computations. In fact, many of the things that I talked about are actually, if you see, follows that principle. Okay? And at a broader level, if you see, the brain is a dynamical system. And dynamical system of a different kind. If we can actually explore that and understand that, we can really get into the next level of AI. And it's a point right now to celebrate AI because we have actually come through this whole cycle to be able to understand its significance. And the most important significance is what? In fact, today, the most unknown thing is your brain. If you look at it, lots of physics problems, there are unknown points, but I think the least known part is brain. Fine? So, the celebration of AI is also a celebration of your endeavor to learn yourself. That is an inward-looking philosophy, which is linked with Indian philosophy as well. That's also is a driver for celebration of AI. Thank you. Yeah.
Thank you, sir, for this talk. One thing you highlighted that currently we have only computing-based AI. So can you please elaborate what are the alternative way?
So I have talked about one thing. One is the DNA computing.
Okay.
DNAs are also actually compute engine. We can model DNA for computing.
Okay.
Okay. The other thing is I also hinted on these organoids, brain organoids. If you see, because it says OI, not AI. Therefore, you pick up the brain cells, neurons, and let them grow. And if you can get them grown on petri dish in a controlled way to do jobs, so it becomes a kind of a collection of these organoids solving a problem.
Okay.
So that actually are the neurons themselves communicating and doing things.
Okay, so has that been realized somewhere?
It has been done. In fact, there is a paper, I think, it is called OI.
Okay.
I think in the Nature Review, there is a recent paper in 23-24,
Okay.
organoid intelligence.
Thank you.
So these are all alternate ways of looking at things, because see, computing cannot handle all of these. If you see that, look at the possibilities, it's an approximation in many cases.
Thank you, sir. So as always, it was a very thought-provoking, talk. So I think I particularly want to ask about the discussion on causality that you had. So just for better clarity, so you're saying that causality aspect is missing. That means the AI cannot right now explain how it came to a decision. Is that what it is?
See, there are algorithms. If you see, explainability has been worked out in terms of these networks, okay? But if you look into it, in the learning itself, there has to be causality. Okay, the point I was telling, that what is cat? See, I know cat on the basis of just the data. Okay, so if there is some different cat from what is there in the data, I shall say that it's not cat. But all possible variants of chair, you can say it's a chair. You're getting my point? So there is a causality of the chair. There is a causal relationship which tells you it's a chair. And if you go back to Judah-Pearl's, formulation, these Bayesian, these A implies B, okay? That is the implication. And if I give B, you are trying to find out the causality A. Fine? So that's a causal inference. Now, to do the causal inference, what you can go through is, you can go through what is what if reasoning. Counterfactuals. You construct a counterfactual to see whether A is a valid under this condition for B. You're getting my point? So therefore, if I given a image, I shall try to look at whether it's a cat or not by looking at possible counterfactuals. Okay? And this kind of thing is also being worked out in AI.
Yeah, but I'm still trying to understand that. See, I mean, if you take the children examples at the end that you mentioned. So now, see, when a child is exposed to only certain types of data, now the reasoning would be based on that. Now,
Absolutely.
but now if a child is exposed to other kinds of cats, which
then obviously that it will generalize, but because of that generalization based on causality, it is not just distribution. Try to understand this. Okay, it does not belong to the distribution, but it can causally link to the distribution. That ability to causally link that to the distribution is currently missing.
Sir, how are we sure it's not?
No. Say for example, see, you know what a cat is. Fine? I have given you enough examples of cat. That's how a child also knows that it's a cat. So if you look into it, a neural network learns the distribution of cat. Fine? And you have given all images of, say, for example, cat with white fur. Okay? Now, there's an example of a cat with black fur. Your neural network will say it's not a cat because it recognizes all the features together. It doesn't build up a causality for what is cat. Okay? If you look into your belief, your standard network, which you use for ImageNet, etc., this causality is not built in anywhere. It is just based on examples. And based on examples, I have the ability to learn distributions and discriminate between distributions. So whatever comes with reference within the distribution, it's fine. But if I have never seen an example of a black cat, it will not recognize black cat. It cannot recognize because your activations will not go towards CAD. Even if it's go towards CAD, it will be below the threshold.
No, but over time I will learn that this is a black cat.
Over time you can learn. But the point is that the child can say it's a cat for the first time when it sees. See, try to understand this. This causality wise, you have the features. See, when you have training because when you talk in terms of this, that when you are training a network for recognition of cat, you are looking at the features, all the features together. Fine? Therefore, it's learning the distribution which is in terms of the vector space of the features. Fine? So, there it is around a particular value of the color. Color is one space. There can be other features also identical, but even then, if you look into it, your space, just look at a multidimensional space. It may not belong to that closer to the cluster. It may be away from the cluster. The problem of drift, which is the standard problem in all supervised learning systems. If there is a temporal drift, spatial drifts in terms of these properties, then the robustness of the classifier is a question. Fine? So, the causality is because I know what is the definition of a cat. But it is not really learning the definition of a cat. It's actually, if you look into it, that's why I said the perception, I have given the example of perception, which is actually in terms of the attributes mapped to. Fine. So, attributes mapped to is a causal model. It's not simply distributional model.
So, sir, how do you see the growth of AI now and down the line, as a positive science or a normative science?
So, I think in a positive sense it will grow. It has to grow because there has been lots of investment. But what is important is that it's important and critical that we should look at a different perspective of AI. The hegemonistic perspective of AI will actually destroy AI. Today it's completely hegemonistic, and it's becoming day by day more hegemonistic. So that's why it is very important to look at alternate models of AI. So if you see to it, why I'm talking about causality in a sense, if you have a causal model did not take huge amount of data. Okay, the whole politics of AI is today with data only. And I have tried to talk about different perspectives of AI to say that you move away from that. There are possibilities of moving away from that.
But when we first learn to walk in our life, that is the first research that we do in our life, right? When we learn to walk, we also need to collect a lot of data.
So that's why I say the perception action cycle will come in. That is, but you did not see, you have never visited IIT Mandi in your life before you came here for a job. But you know how to find out things in IIT Mandi. You had an abstracted perspective and the logic for finding that out. That causality, what is missing in today's system. And that's why causality, that's why if you see that Russell's picture, that I perceive an act and I causally analyze. That's what is that of a behavior of an agent.
Sir, so I just want to ask a question about something that you said in the early part of your talk about AI moving in the realm of science and as a scientific discipline, and us being able to find out certain principles which are along the line of how scientific method works. As I see how the brain in fact works, and as far as we know, this is the best example of intelligence around known universe. It's just an emergent phenomena of a bunch of switches connected together, neurons connected together.
But that's where the science lies, na? If you can get the science of figuring that out, then you know how the brain works.
But there is no upper limit as far as we know to intelligence, because
forget about upper limit. Why do you want to talk about upper limit? We do not know what is there in the universe.
So how can we find some fundamental principles?
But still in the universe we have found the fundamental principles, at least with the approximation of the current universe. Your laws of electromagnetic wave propagation, Maxwell's equations are valid. It may not be valid in anti-universe. Universe of antiparticles, it may not be valid. But given the definition of your universe, it's valid?
Yes.
Okay. So therefore, given the universe of how you define that of your intelligence space, you can come up with basic principles.
But my problem is our reference
It's
is
a
essentially
biological principle. Biological principles may not be like a kind of a physics law. It can be a statistical principle also.
yes. So that's my. In fact, I do firmly believe that even
It's a
causality will
statistical.
eventually come into statistics.
Yeah,
That's my personal opinion.
So the causal model also has to go to statistics. In
It
fact,
will.
Today there is already machine learning algorithms which uses causality.
Right.
Okay? So it's not that it's not there, but the point is today what we have to look at is the perspectives have to change
Perspectives of.
this machine learning,
Yeah.
that is moving from data driven. One is data driven discriminative model and data driven generative model where we are going into.
Okay.
But both these cases can have alternate way to do things. Okay? See, it might be that everything is, you do not know everything. Look at the things. You have the ability to actually explain things which you have never seen before. Because you have got the causal physical model built in your mind,
Yes.
which is, you say, even say common sense physics. Okay? That common sense physics today, we do not have any tools really to model and learn common sense physics. It's a qualitative physics. So all of these are actually how you learn in your brain those things. A child knows qualitative physics. He has not read the physics laws, but that gets built up by interaction with the external world. That's what I showed that case, this perception action loop by which actually you create that whole perception of the world. And the perception of the world is what you sense. But how does that get programmed into your mind? What is the theory for it?
I'm not arguing at this point, but it just seems like just another additional level of restructured neurons or different type of neurons, because many.
But the point is that there are some emergent principles which are coming out of that.
Yes.
So that emergent principles can allow you to actually do things which are in your AI. Try to understand what I'm trying to say is that, see, we have not solved the problem of brain.
We haven't.
Fine?
Yeah.
So there are lots of unknowns in the brain, how the brain works. If we can explode the things, because I have talked about a hypothesis of educability, it came from a computer scientist. I can give you another hypothesis which says that if there is a predator-prey reaction, these are all reflex actions, and reflex actions are also intelligence. But reflex actions does not require educability, but how they are intelligent. Fine? Okay? So therefore that is at some level intelligence, educability at some other level intelligence. Now how do I understand these levels of intelligence?
I think it's recursive. Human intelligence can subsume everything.
Yeah. So
but I can imagine an intelligence which.
Even if it's a recursive,
yeah.
you have to know the recursive equations.
Yes, and that's a problem with complexity itself.
Absolutely. Nobody is denying that fact. That's why computer science comes in. Whether computing platform is the platform for it, that's another question. I'm not denying, because computational, if you see even in the end when I said, all cognitive scientists have also talked about a computational layer, okay? A computational layer in the brain. Even Marr has talked about computational layer in the brain. But that computational layer need not be always implemented by the computer that you're talking about.
Of course.
Okay? So that dissociation is something which is very important.
Agreed. Fully agreed.
Thank you, sir, for the very enlightening lecture. I'd like to get your opinion on computational functionalism, the way it's defined over here.
Yeah.
So, is that possible? Do you personally subscribe to it, or
Can you just repeat the question?
So my question is, what is your take on the definition of computational functionalism and its reference to consciousness in AI? So I couldn't connect the two when you were including.
So, computational functionalism in the sense that, see, how consciousness is being used for achieving a function in computation. Just look at your LLM. Okay? In the LLMs or any of these today, this we use, where if you look at this paper, the attention is all, right? So I use self-attention, direct self-attention, multi-headed self-attention, and cross-modal self-attention. So what does attention, self-attention means? Self-attention means essentially that, just look at in a very simplistic sense, that given a sentence, when I refer to a word X and there is a co-reference to a word Y, which may be anywhere in the text, I can actually connect the two things because I have paid attention to that. Fine? Attention mechanism is a conscious mechanism. I cannot pay attention, if I am not conscious, I cannot pay attention to your face. Okay? And by paying attention to your face with reference to my position, I can actually interpret your physical position and what you are talking about. So that is the computational perspective of consciousness of AI today. There has been lots of other theories of consciousness I have not gone into, because why I touched upon consciousness is that because you cannot talk about human brain, human intelligence without consciousness. So if I have to go to AI, I have to bring in consciousness. Because without being conscious, I cannot be possibly contextually intelligent. So I am looking at, therefore, at a lower level of the concept of consciousness. Consciousness can be at multiple levels. So it's a computational functionalism is being used as for defining consciousness in the realm of AI, which actually attention is the earliest example of that.
Good evening, sir.
Yeah.
Here.
Somebody on top.
Yeah.
Yeah, this is the last question, please. In the
So, sir, I had a bit confusion about the educability of AI models. During the start
No,
of
not
the
educability. I have not talked about educability of human models. What I say that human beings are educable.
Yeah. But you mentioned 2 points, like when you were talking about CNNs and their ability to classify images, you were saying that it is different from the instruction ability of animals, that they are able to see, they are able to learn the instructions from data, but they also have the ability to perform the actions. So I think at that point you mentioned how they are different from the instruction ability of animals, and during the end of lecture you mentioned that AI models are not educable because they are not able to take
I
in
did not
context
say
the
I want to say not
causality.
educable. I said that being completely educable, if you look at all the 3 criteria for being educable, today's AI models do not qualify to that. Okay, that is the ability to assimilate and reason and do things. To that level, AI models have not matured. That's what I said. Human beings, the educability of the human beings has been illustrated by the fact that human beings have created civilizations, they have created society, they are controlling everything, because they can actually think, what I said, that think beyond what is probable. The moment I have a learning system which is constrained statistically in terms of the distributions given the data, the generation is constrained by what is there. If you say your generative model is based on what? I learn the distribution effectively and I generate points from that distribution. It's not something which is not there at all and I can think about something. The example I gave, that mobile phone, you cannot have a mobile phone, it has been perceived, conceived and thought about. It's a creativity. Your artificial intelligence today does not have that creativity.
So I actually have a thought in mind that the current AI models are as similar as the instruction ability of organisms other than humans, but I got a feeling from the lecture that the current AI models are able to perform more actions than the instruction carrying ability. So can you give some clarification?
Yeah, instruction carrying, see, the point is that, okay, if you say the instruction carrying capability, try to look at it. Now AI has a limited capability of generation. Fine, generation is not just instruction capability. Generation is ability to generate combinatorics, that is combining things and generating something new. Okay? But what is the limitation? Limitation of AI is based on the domain of the distribution that it learns that it has. The distribution can be as complex as possible, but doing something beyond the distribution. You're getting my point? Doing something beyond the distribution is actually an example of or demonstration of educability of the human beings. Okay? Human beings have created civilizations which are not there. He had never seen them.
So I understood the difference.
So I think we should stop here because I think
Sir,
we
a
are running
last
out of
follow-up
time. You can meet Professor Chaudhury a little bit later.
Okay,
Yeah,
sure.
thank you. Sir, can we close?
Yeah.
Okay, then thank you so much. We can thank the speaker once again for this very freewheeling talk. Now I request Director to felicitate the speaker.
So we thank Professor Santanu Chaudhury for coming here, and in spite of his very packed schedule, he agreed to deliver. In fact, we wanted to celebrate that this year's Nobel Prize was given to both physicists as well as chemists in the area of AI. And he is my PhD supervisor. I learned neural networks from him. And it is a sweet memory that when we started teaching neural network, we taught half-filled network, associative memory. We realized a noisy pattern can be recovered when you excite using a half-filled network. We also learned Boltzmann machine, restricted Boltzmann machine, and so all those things are very in our memory, and so we must celebrate this Nobel Prize given to this, and I think Professor Santanu Chaudhury made abundantly, put a lot of effort in taking us that journey from beginning to the end and saying that there is a possibility of atom bomb getting exploded. But beyond that, his contribution in this field is immense, and obviously the talk was very philosophical in many sense. I hope you enjoyed it. Thank you, sir.
Thank you. Thank you.
So anybody who would like to ask, interact with Professor Santanu Chaudhury, on the way you can have certain interaction. He particularly works in multiple areas, but his recent thing is science of intelligence. It is very fond of. We don't all agree the way AI is going in a direction, but AI has its own potential in many of our field, and we can give a proper direction. I think science of intelligence that he is advocating is something very, very interesting. We always talk about AI, also we talk about natural intelligence. And can we have a bridge between these two? Is something multi-billion-dollar question. Thank you.